Hey, what's up, you guys? It's Saturday with Mr. Kim, and I am here to do the magnesium chloride lab for those of you guys who are absent so you can have some data and write your formal lab report, succeed, and be successful in life. Okay, so let's get started. Um, let's get started. What lab? Oh, magnesium chloride lab. Let's do this. Okay, so the first part of the procedure, first of all, wear your safety gloves. I'm wearing my safety gloves. Although I'm holding my iPhone with my left hand, it's still 100% safe in this laboratory environment. So the first part says to obtain a piece of magnesium ribbon and find its mass to the nearest 0.0x grams and record on the data table. Do not round your numbers. So I have this strip of magnesium over here. I'm just going to put it directly on the scale, and that says, whoa, wait a minute, the scale is... Okay, so I pre-measured this before and it came out to 0.12, so take my word for it. I gotta I don't know why this scale is acting up, but it came out to 0.12 grams, okay? And so over here, mass of magnesium ribbon is 0.12 grams, okay? And it says to find the moles. You guys can do the moles. I'm not gonna solve for that. Now it tells you to find the mass of the empty evaporating dish. So actually, let's just look at our procedures. It says to convert the grams to moles, show your work including dimensional analysis, then obtain an evaporating dish and find the mass, record on the data table. Again, do not round your values. So here's the empty evaporating dish. I don't know why this scale is going crazy. Alright, well, maybe it's because I'm near. It's the force of Mr. Never mind. So we have 47. I think the scale is just going down too, for whatever reason. So I'm just gonna say it's 47.21. So 47.21. Where are we at? Right here. So 47.21 grams for the empty evaporating dish. This is the evaporating dish. Okay. Then it says to place the magnesium in the evaporating dish and slowly squirt a few drops of 6 molar, that's a concentration, hydrochloric acid into the evaporating dish and complete the step before heating. It says, careful, do not breathe into the fumes. Your nose hairs will disintegrate and your lungs will cry. That's a bit of an exaggeration, but that's just so that you guys can stay clear away from all the hydrogen gas that and the hydrochloric acid vapor that kind of might do that to you. So here we go. I just folded the magnesium ribbon just so that there is greater surface area when I add in the HCl. This is 6 molars. Here we go. I think I want to kind of stay away from this, but let's see. And here we have a reaction happening. The fumes are getting close. I have safety goggles on, so I will not die or suffer any injuries. So there's a reaction happening. They have solid magnesium and hydrochloric acid. So you guys should know what type of reaction that is. I'm not going to tell you, but I'll give you a hint. It rhymes with single complacement. That's not a word. Single replacement. Okay, it's a single replacement reaction that's happening. So I just gave you some answers. Single replacement. Okay, as you can see, the bubbling kind of stopped. So I'm just going to add more HCl because I want this magnesium ribbon to completely disintegrate. It should just be like a clear solution by the time everything's done. Okay. Now the reason why you don't want to add just a whole bunch of HCl is two reasons. One is that you're going to have, it's going to take forever to evaporate all the hydrogen out, and second, you don't want too much chlorine just kind of hanging out there because we're going to get wrong, inaccurate data. The whole point of this lab is to find the empirical formula of magnesium chloride. So if you want to try to use as small amount of HCl as possible, so that we can be successful in life. That's what life is all about. Being successful and loving and caring for other people. I hope I'm not covering the mic right now. Yeah, I'm not covering the mic. I think we should be good. Alright, so it's disintegrating. I'm going to take some more HCl just in case. You always want to be prepared in life. Who knows what might happen. Okay, look both sides when you cross the road. Have your HCl ready before you squirt HCl into the magnesium metal. It seems like we need some more. So I'm going to squirt some HCl over here, like so. Okay. I kind of want to do a retake. I take two. I feel like I just woke up, you guys. Alright, looks like it's disintegrating well. Yay. Okay. Alright, this little piece still hasn't disintegrated. I think it will though soon. Come on, little guy. Waiting on you. Alright, good. It's disintegrated. Okay, so now it says when all of the magnesium is dissolved, place the evaporating dish on the hot plate. Turn the hot plate to about 5.5 to 8 on dial and try not to breathe the fumes. Okay, so I'm going to do that. It's already at 7 right now, so I'm going to place it like so. Alright, and I'm just going to wait until all the liquid evaporates. I'm going to kind of read ahead. When all of the moisture has been driven off by the hot plate, which takes about 5 to 8 minutes, remove. Okay, after I remove it, I'm going to record the mass of the evaporating plate along with the magnesium chloride that's in it. Okay, so I'm just going to see if I can crop this video. Maybe I'll just record everything actually and then crop later. So here, as you can see, okay, we see some bubbling happening. It's going to get all that liquid out and all the hydrogen gas. It's like we're cooking ramen in chemistry class. That'd be pretty cool. We can study how much energy is released in our bodies when all the MSG and its glory from ramen, oh shoot, so much fumes, enter our system. Okay. All right, so looks like we're doing pretty good, pretty well, pretty good, pretty good. So while we wait, let's just kind of go over the lab a little bit more throughout. So here, a lot of students made this mistake where it says show work here, right? These show work here boxes. You want to show the work for whatever came before it on the bottom. Okay, so like for instance, when you're finding a wait a minute, mass of magnesium chloride residue and evaporating dish, that's just you adding these two values together. You're gonna show the work right here. So actually, let's do it together. So mass of magnesium is 0.12 grams, and then mass evaporating dish is 47.21 grams. It's hard to do this with one hand. 47.21 grams. So you add them up together and you get 47.33 grams, right? And that's what you're gonna put right here where it says mass of magnesium. Whoops. That's the total. So to find the mass of magnesium chloride, you have to wait until this finishes. Okay, so this value over here is the magnesium plus, I'm just going to call it the evaporating dish, the E dish. Okay, now once we have, before that, okay, as you can see, some precipitates forming. Once we have all the magnesium chloride, what we're going to do is re-measure it, and we'll have the evaporating dish plus the mass of magnesium chloride. So as you can see, all this precipitates forming, right? It almost seems like out of nowhere, but because it was a solution before, we couldn't see it. It was clear and homogeneous. Now, because all the hydrogen gas is off, there's no more liquid, or almost no more liquid. We just have magnesium chloride salt. Okay, so although it seems like everything is dry and good, I'm just gonna wait just about 30 more seconds so that I can make sure that there is no more trace of any kind of liquid. Okay, because we're using, a scale that can only go up to the 100th place, and we really didn't control exactly how much HCl we needed. We just kind of eyeballed it to see, how much it would take for it to completely react, right? There is going to be a huge margin of error. Okay, you might be lucky, you might get everything correct, and that's good, but it's okay because that's what sources of error are for, and that's what the percent yield, the percent error is for, and you can always explain why. Okay, all right, so it seems dry. Now if you're taking this lab like 110% seriously, and we have 2 hours to actually do this lab, you might want to keep this on for like another 10 minutes and compare masses, and just make sure that the mass after heating for 10 minutes and the mass before that, the values are only off by a very, very tiny amount. So you know that everything has evaporated out. Okay, but I'm just going to take this, let's turn the hot plate off, use some tongs, right, for safety. Ooh, almost broke that. Use some tongs for safety. Bring it over here. I'm going to let it cool down for a sec. Oops. I don't know if you can see that. There we go. No. There we go. Okay, got magnesium chloride in there. All right. I'm going to put on the scale. Remember, the scale kind of fluctuates by 0.2. I've always taken the lower value, or 0.02. So I'm going to just do that like so. And that is 47 so it looks like it's going down to 47.57. So I'm going to put 0.02 up, just like I did for before. So 47.59. Where is it? Magnesium chloride, residue, and evaporating dish is 47.59. So magnesium chloride only would be this minus that, right? So I actually made an error right here. I'm sorry, you guys. I got ahead of myself. So 47.59 minus 47.21, the empty evaporating dish, will give you 59 minus 21. Okay, will give you 0.38 grams. So the mass of magnesium chloride is 0.38 grams. Okay, mass of magnesium was 0.2. So when I ask you for the mass of chloride, right, I say chloride because it's a chloride ion. Okay, I should have actually said chlorine. No. But to find that's simple, because law of conservation of mass states that we can't create or destroy any new matter. So if my total mass of magnesium chloride is 0.38, and I know what I started out with for magnesium, which is 0.12, just subtract, and you have the mass of chloride. Minus 0.38 grams, or 0.38 grams minus 0.12 grams will give you 0.26 grams of chlorine. Actually, this is going to get really good data. Okay, 0.26 grams of chlorine. Okay. Then next, you want to find the moles of chloride. Okay. Compare it to your moles of magnesium, and then you can find the empirical formula by doing the ratios, right? And then compare, right? Use the percent composition. So once you find the empirical formula, use the results of A and E, so that's the value that you guys measured to find the percent composition of magnesium and magnesium chloride. Show your work, and then compare that to the theoretical value of 25.5%. 25.5% for percent composition. And that's how you're going to get your percent error and see how far you guys are off. Okay. Once you do that, you have these questions that you're going to answer. You're going to turn this entire packet in with your formal lab report. And that's it. So I hope you guys enjoyed that. And I will see you guys on Monday. Have a good one, you guys.